And greetings and welcome, friends. This is video 499 from my YouTube channel, but don't let you think that there's 499 unique videos, because there aren't. Some of them are duplicated for whatever failures on my part. And some of them are just terrible. So let's see. Find the polar coordinates. Wait, what are we doing? Polar coordinates? That's right. We were last night converting between polar and rectangular forms. We learned a handful of little tricks up our sleeves that we could convert between the two. So we had a handful of little formulas that you need to know. And so we're on page 572 by the looks of it. Here's question 15. This one's particularly intriguing. I might even draw a picture of this just to analyze the situation a little bit better here. So 0, 1 is right there. It says find the polar coordinates, blah, 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 blah. So now let's see. That's actually weird. They started kind of almost backwards. So if I want to find r, you might recall that there is the r formula is equal to the square root of x squared plus y squared. So that was one of the new tricks we learned. So r is going to equal the square root of 0 squared plus 1 squared, which is the square root of 1 squared, which is 1 for the value of r. Now for the value of theta, you might realize that the arctan or tan inverse of y over x is kind of how you'd analyze that, so to speak. I might even write it this way. What if I said tan theta equals y over x? Because the two formulas that the book gave us specified situations in which when x is less than 1 or greater than 1, and a student a moment ago pointed out that French people are better at math, and that 0 is neither less than 1 or greater than 1. So if I wanted to find theta, I would say, oh, tan theta is equal, that looked like I said tau, tan theta is equal to y over x, and you might be like, that's straight up undefined. You can't divide by 0. However, think about it this way. Mentally, we might be able to figure this out. Tan inverse of undefined is asking the question, for what angle theta is tangent undefined? And it turns out that's 90 degrees. Now, I don't think you could plug that into a calculator, although I have not tried. Let me try that right now. 1 divided by 0. It says, yeah, error divided by 0. It can't get past it. But, yeah, it turns out that theta is equal to 90 degrees, or I guess here they specified that it should be radians, so better yet, theta is equal to pi over 2. So my r thetas is going to be 1 comma pi over 2, like so. The other thing, if I drew a picture of it, you might have realized that, yeah, that's like 90 degrees. And also that this distance is 1. So yeah, it's an interesting case, so I'm definitely glad that we did this nonetheless. It is somewhat intriguing, friends. Let's take a look at this next one. Can we do it the other way? Find the rectangular coordinates of each point given the polar coordinates. This will require me to know this little fact. X is equal to r times cosine theta, and y is equal to r times sine of theta tot. So let's see. These are r and theta. Oh, we had tater tots for lunch? I thought it was pizza lunch. Oh, okay. All right. Hot diggity dog. So let's see. X is equal to 1/2 times cosine of 3 pi over 4. Cosine of 3 over 4 is, let's see, that's a reference angle. That's a second degree, or second quadrant, sorry, so it's negative for cosine. The reference angle is pi over 4. Cosine of pi over 4, that's root 2 over 2. So this is going to be negative root 2 over 4, if I'm not mistaken, for my x. And for the y is going to equal 1/2 sine of 3 over 4. Once again, that's a second quadrant angle, which sine is positive in that quadrant. The reference angle is pi over 4, so that's root 2 over 2. Fortunately, we're masters of
Yeah, I was
r.
going to say, how do you know that pi over 4 is root 2 over 2?
Hand trick in it. That's 45 degrees.
Do these represent pi things too?
Yeah, man, you're never gonna look at your fingers the same. You're just like, what? I can do so much on my fingers. So crazy. Like count to 10. Yeah, good stuff. Let's see, 31. Oh man, guys, that's what really should be my 500th YouTube video. Because my son Everett now can like sing the Skyrim theme song where he's all like da 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 da, and like it's awesome. He does not sing it; he's just making those noises I just did. So I want to get him like this awesome like Nordic ram's horn helmet and like awesome like skins, and just have him running around the village like singing like Skyrim music. That would get so many hits. He would be the cutest 2-foot tall Nordic Dovahkiin ever. It would be amazing. I'd love it.
By village, do you mean the village of Wilmington?
The village of Wilmington, yes, and you'd perhaps see dragons flying over to attack, and he would like kill said dragon and then absorb its soul so he could like do some dragon shouts like all. Oh, I also taught him how to say Fusro Da last night. True fact. So anyways, check out this. It says write the rectangular equation in polar form. So I'm gonna want to like switch these x's and y's, guys, over to other forms. Actually, wow, I just thought of a completely different strategy for this. There's a few ways I think we could do this. X is equal to r cos theta, and y is equal to r sine theta. I could use that. I also, if I expand this first, I might actually even be able to use the x squared plus y squared is equal to r squared sort of trick. So handful of things I could do. I think in the lesson, I think I did some switcheroos with these first and then expanded this using a pattern, specifically this pattern, a minus b all squared is equal to a squared minus 2ab plus b squared. So to do this problem, you kind of had to come with some previous knowledge, so to speak. I'm actually interested, I want to see if I can use this route. I don't even know if it'll corner me or not, but y minus 2 all squared is going to become y squared minus 2 times y times 2 plus 2 squared equals 4. So that's x squared plus y squared minus 4y plus 4 equals 4. Oh yeah, this will work out just fine. And x squared plus y squared, I realize I can replace with what? Also, I taught my son how to say what in reference to the commercial with the camel on Wednesday. I believe it's a Geico commercial. I can also substitute right here this y for this guy. And minus 4 times r cos sine theta. Man, I just almost got a Glavin in there. What's the name of the professor in The Simpsons? I can't think of his name. Well, so subtract 4 from both sides. I thought it was just he was cold. R squared is going to equal, if I move this to the other side, 4r sine theta. Technically, this is in a polar form right now. And the book does this move. I'm still like super cautious about doing this. This in my mind is like, ugh, man, real scary. I think this is like sketchy math. I don't know where they learn to do math, but r equals 4 sine theta. If I divide both sides by r, I can kind of get rid of that. Yeah. So there you go. This, I believe, ends up being the equation of a circle that is kind of like this. If my grid is there, seems to be the case. That actually almost looked like some sort of Ankh. What was that? Right? I don't remember. I can't think of my Egyptian character stuff. But yeah, so, and notice the rectangular form is also a 0, 2 centered circle with radius 2. So those would actually represent the same thing. And last example, write each polar equation in rectangular form. How wonderful, friends. Let's see. Let's see what tricks we can do here. Guys, you know what? We don't know what to do with a sine 2 theta unless God.
Of course.
Dingleberg. Yeah, I mean, seriously. Some other tricks you might be able to use. I'm going to use this and this one. If you try to use, to swap out the r squared, which I'm guessing is probably what you guys did, you had x squared plus y squared in parentheses multiplied by sine 2 theta. And the problem is you then have to find a way to deal with the theta here. Yeah, which I mean, yeah. What are you even going to do with that? You'd be trapped. It's a trap, is what Admiral Akbar would tell you. So let's swap out for sine 2 theta using my no, not a Pythag identity. It's trigonometric identity for a double angle identity here. So r squared times 2 sine theta cos 2, or it's just cos theta, sorry, equals 8. Right. And watch this old trick. I'm going to take this r squared. I'm going to put 1 in front of the sine theta and 1 in front of the cos theta, using just like commutative property of multiplication, you know. So 2r sine theta, r cos theta. Why do I like that?
R is equal to x.
Right? Yeah. So r sine theta, that's just going to be y. And r cos theta, that's just going to be x. So this is just 2xy equals 8, which I could divide both sides by 2 to get xy equals 4. Which I don't know if you guys are friends. And this is the answer. I don't know if you guys are friends with your conics. Actually, let me even show you a nice. Here we go. Let me get a nice little snapshot. And paste this in here. So this is actually what's called a rectangular hyperbola. The square root of 4 is 2. And I'll have one vertex at 2, 2, and the other one's at negative 2, 2. This, by the way, changes if I had a minus sign here, then the vertices would be at this location and this location. And the asymptotes for this are actually our axes, oddly enough. So I have hyperbola like so. Yeah, something like is what that actually looks like. Pretty cool stuff, which means that this guy also represents that hyperbola. But in order to do that, you'd have to solve for r. Actually, let's little bonus content at the end of this video. R squared sine 2 theta equals 8. R squared times sine 2 theta, not squared theta, equals 8. That's not an 8. There we go. That's a sad 8. There we go. If I want to graph this polarly speaking, I'm going to have to solve for r. So I'd get r squared equals 8 divided by sine 2 theta. And then I'd have to root both sides, and I'd get r is equal to plus or minus the square root of 8 over sine 2 theta. And let me pull open this little, where's my polar graph? Here we are. Bam. So let me graph this guy here. So t of theta, that's the same as r, equals the square root of 8 divided by sine 2 theta. And if I graph this, what do you know? Look what I get. Also, looks like I peed in the corner there. If I graph the negative version, because remember it's plus or minus, I technically would have to graph the negative version as well. Guess where the negative version goes? The same exact place as the positive. So it turns out that this graph happens to have been mapped over itself twice as theta traveled from 0 to 2 pi is what happened. So yeah, I end up with that, and these vertices actually would be at 2, 2. Yeah, that looks weird, but it is right there, yeah. If I rectangularly perceived this. So anyways, thanks for watching, friends. Have a great day. Bye-bye.